Okay, so this is insertion sort. Let's have a quick look at some theory behind it. Insertion sort is called insertion sort. It's because you are literally inserting the current item that you're looking at in the right place in the array. It's very similar to bubble sort. In fact, you could program it similar to bubble sort if you wanted. Here's a graphical representation of insertion sort. So basically, instead of like kind of looking at the current item and the one in front of it and comparing them, we're going backwards. We're looking at the current item, like say the current item is 12, that's index 1, and we're looking at index I minus 1 or 1 minus 1, which is at index 0. We're comparing this one, this one, this one, if we're going to sort in ascending order, is less than 85. Therefore, we need to swap them over. How are we going to swap them over? Well, we need to shift them up this way. So put 85. So we need to save that in a variable called current, and we need to insert that into this position here. So there's basically the code is structured. Skip to this pseudocode. Try and write it from this if you can look at this. It's a good idea too. We've got an outer for loop that goes from the index I, but 1, sorry, to the length of the array. We're saving the current item we're looking at, and we're copying this index into this index 2. And then we've got an inner while loop. So nested loops, rings of polynomial n squared. So it's not any better really than bubble sort. It might be slightly more efficient. And then this inner while loop is going back. So it's making sure that this index is never 0, because if it is 0, we're going to go to -1 and there is no index -1. And then we're making sure that then we do this swap in the middle, or we do this shift here in the while loop if the thing at index -2 if that thing for it is greater than the current one, right? If it is, then we need to put it into its right place. So like this. So for example, we know that we need to swap these two because this one is greater than this one. So we put that into there and we insert into there. Then we move the counter on to 2, and we're comparing 2 and index 2 and the thing at index 1, 59 and 89. 85 is greater than it. So we need to, this is saved in our current variable. We're shifting 85 into here, and then we're going to insert 59 into here. Because we don't need to swap it, because 59 is greater than 12, and then we move our index on to 0, 1, 2, 3, and we're comparing the thing at index 3 and the thing at index 2, and we're comparing those. 85 is greater than that, so we shift 85 into its position, insert it into there. Then 59 is greater than 45. So we shift 59 over into its position, and then finally we insert that current item into it, 45 into its rightful place there. So this shifting back is this while loop here, this inner while loop, where we're looking at the current item and the one before it and seeing if the one before it is greater than it, if we want to do an ascending order, and then we are shifting it, the one before it, into its current position. And then after the while loop, we are then updating the array with the item that we've saved in current, so that we're making sure that we're inserting that current item into the right place. So as I said, it's polynomial n squared, really bad algorithm, to be honest. Like after a certain number of n's or numbers, it gets very, very slow. So you'd only use it for very short arrays. Actually, someone tested this last year in about 10,000 items in an array before it kind of gets worse than some of the more optimal algorithms, the log n algorithms. Why else would you use it? It's simple to write, as you'll see. Sometimes you just want a quick, short algorithm to write stuff. And also, you need to know this to pass the exam. That's why you need to know it, really. If you look in the link below, I've got this broken down into steps piece of code. So this is the pseudocode. Maybe you can write it from that. Maybe you can look through these steps here. That describes what you need to write in the code. You need to have an input or a list, an array of numbers to sort. Then you need to have a for loop, which we loop over until we get to the end of the list. So we set up a for loop. Then we're copying the current index in that for loop into another variable. Then we're saving the current item because we need to save this before we get into this while loop so that we can insert it in the right place. Yeah, so I keep referring back to that. So once we've kind of gone back as far as we can, we need to make sure that this current item 45 can be inserted into its current correct place. The while loop needs to decide, is the current index greater than 0? If it is, then we can enter into the while loop, but also, is the thing before it, is it greater than the current item we're looking at? Is 85 greater than 12? Yeah, it is. Therefore, we need to do a swap. The swap is done by saying the thing at the current index, like 1, for example, or at position 112, we need to change the value in there to 85. And then we need to take 1 off the current index because we need to kind of go back through the list. And that's why we need to keep checking if it's greater than 0. After that while loop, the last thing we need to do is we need to insert the item that we've been comparing to all the other items before it into its correct position, which we will have at that point. For example, here, we know 45 needs to go into position 1 because it's greater than 12, and so it doesn't need to go there. We don't need to do another swap. So that's why it's called insertion sort, because the final thing we do is we insert that current item we're comparing into its rightful place. Okay, so if that's enough information for you to go on, which it kind of should be, try and code that. And again, this is in the Word doc in the link below. Right, so let's show you how to do this quickly. Insertion sort 5. I practiced this quite a bit. What are we going to do? The first thing we want to do, because we love functions, don't we? Functions are great. They break up code. They make it more reusable. We're going to create a function. The function is going to be public static. It's going to return an array of integers, and it's going to be called insertion sort because that's what we're doing. Going to take an array of integers let's call it unsorted. Then we're going to create an array in our main function. So your program in a console line app starts in the main function. It's going to be called unsorted numbers. And I'm going to put some random numbers in here that are in the wrong place. So put some minus numbers. Right, that's enough. We're going to call this array up, and we're going to pass this into it. And then we're going to print the result out into the console so we can see. So insertion sort. We're going to we can't print. So this is going to return an array, but we can't just print an array directly. You have to use something called string.join. String.join will join every element in an array together with a connecting item. We're going to say a comma. So, and then it sort of loop through it in one line. It's kind of a really handy thing to know about. And then what do we want to turn into a string? We want to turn into a string the result of our insertion sort array function, and we're going to pass in unsorted numbers into that. So we haven't actually written the function yet, but when we do write the function, that it's going to return the sorted numbers, and then it's going to turn that into a string printed to the console so we can see whether it's correct. Okay, so that's like just the input of numbers and creating the function. The next thing we need to do is these two steps, which is basically I'm trying to write out of just describe a for loop in steps or pseudocode. So we need the for loop. We need a index, a counter I. While I is less than unsorted dot length. Then we're going to add one on, right? While it's less than that, we're going to add one on. So as I said, I could probably start at 1. It should probably start at 1. Why? Because there's no point looking at the thing at 0 because there's nothing to compare it to before, and we can't go to index -1 because 0 minus 1 is -1. And that doesn't exist. You get array out of bounds. So we start the loop at 1, right? We start the loop looking at 12. We're going to need to save our current item. We're going to need to save it in here. So this item, we're going to need to save it in there. Because this we are going to keep shifting numbers into its place. And then we're going to finally use that to insert it in its correct place at the end. We also need to copy current into a variable, the counter I into here, because we're going to need to take 1 off that every time to go back with our while loop. So then we've got our while loop. Our while loop looks at current index, this thing, checks to see if it's greater than 0 because we can't go to -1. And then if it is, we're going to take this unsorted array and we're going to say thing before it, current index -1. Is that greater than the current thing that we're looking at? Is it greater current? If it is greater, we need to swap them over, or we need to shift this one before, the 85 before, into its position there. So we need to say array to sort current index. And what we're going to put in there, we're going to put the thing before it. Array, sorry, it's unsorted, isn't it? We're going to put the thing for it. So current is going to be equal to current index -1. So the thing 85 is now going to be put into the position where 12 is, but we're not overriding it because we've saved 12 in here in current. The last thing we need to do is, well, we need to update this current index thing by taking 1 off it, because we need to go back in the array. So for example, when we were at 45 here, we need to go back to -1 before it, and then we need to compare 45 to 59, which would be like compare 45 to 59, and then if they need to be swapped, we need to put it in its position. So we kind of need to take 1 off this current index to go back. So once we've got to the last possible place we can, i.e. the current index is 0 or the one before it is not greater than it, the while loop quits, and we know that we've got the right index to put this current item that we've saved. So we know that we've got the right index to insert 45 into, which is going to be here in this list, position 1. So we need to say array, unsorted current index, and that is going to be equal to current, this thing. So this is the insertion of the current item in the correct place we have got from comparing previous items to it. So that's the difference between bubble sort and insertion sort. We're basically trying to find the right index for the current item we're looking at, defined by I, to insert it into that position in that array. Yeah, and the last thing we need to do to make this function happy is we need to return unsorted. And that will return it back to here where it will print it to the screen. So if I play that now and give that a minute, it will take all these numbers and sort them using our insertion sort function. Just a quick recap, we've got this unsorted numbers array. We're calling up insertion sort with it and passing in that array into here. Yeah, we've got to do the return outside of the for loop because we don't, yeah, slight mistake there. So I'll run that again. So we're calling up that. Then we're doing this for loop. The for loop is going to go from 0 to 1, 2, 3, 4, 5, or we've got 1, 2, 3, 4, 5, 6 in our array. I could do the same one as in this example. You can do that if you want. So we're going to go through every position. We're going to get the current one that we're looking at. So the current one we're looking at is always going to be the first one, so 12. And then we're going to copy the current index as well, so we can take one off it. We're going to compare the one before it to the current. If that is greater than that, so we're sorting in ascending order, we need to do a swap. But also current needs to be greater than 0 as well. So we need to check that first, as we get array out of bounds. If it is greater, we need to shift the one before it into the current position. So we're doing that. So let's put a comment. Shift the one before into the current item's position. And then we need to take one off the current index. So so that we can go back through the array to find the correct place for the current item. Yeah, so that's what we're doing here in this while loop. And the while loop obviously is the while loop. Let's put a comment. The while loop checks if the one before is less than the current. If it is, we need to swap. Yeah. And also we're checking whether that is greater than 0. And here we're saving the current so we can insert it into its correct position. And here we are copying the current I counter. So we can manipulate it and take off that. Yeah. Right, and that will produce that. So there you go. Quick summary, insertion sort, very similar to bubble sort, but we're just comparing items before it. And the main difference really in the way you write the algorithm is that you're looking at the thing before, and if you're doing in ascending order, and if it is less than it, then you shift the one before into the current position. But we've already saved the current item here, so that once we've kind of gone back as far as we can and made sure that the current item, like in this case 45, is not less than the one before it, then we know that we need to finally put that current item into its correct place using that index, right? And that is basically it for insertion sort.